Good morning everyone. So today we are going to discuss about the most economical channel section in open channel flow. So this is me, Dilruba Kiyum. So let us straight away get into the topic. What do you really mean by the most economical channel section? When the term economic come into our mind, we will have a feeling that it is just to reduce the construction cost, right? But we are talking about the hydraulic structures, hydraulic open channels. Does that help just by reducing the construction cost? No, right? So what is really matters? So what we really want is not the most economical but the most efficient one. So by the way, what is this most economical and most efficient? We cannot, when we say efficiency, we cannot reduce the quality of the structure, but but we have to reduce the cost, right? So let us see how can we convert this most economical channel section to most economic efficient channel section. So the most economical channel section means we will have minimum cost of construction, and when we talk about most efficient channel section, we should have a maximum discharge. So when we couple both this, add up both this, we will get economical as well as efficient. Okay, so efficient and economical channel section means we should have a maximum discharge for minimum cost. So let us see how can we do this. We know the equation for discharge. Q is equal to AC root mi. So I'm just finding out how can we maximize the discharge. We have here in this equation C is Chassis constant and M is hydraulic mean depth, which is equal to area by perimeter. So I'm just substituting the value A by P in the term M in this equation, and the equation will become ACA root A by P into I. Okay, so it will be AC root A into I divided by root P. Okay, so my aim is to maximize the discharge, right? So in order to maximize the discharge, I can either increase this numerator or I can reduce the denominator. In either way, I can make this discharge maximum. So when I consider the first condition, that is increasing this numerator, here C and I are constant, so we must increase area. When we increase the area, the section will become non-economical. It is not economical way, right? So it is not economical to increase the area, so that option is not here. Then our second option is reduce the perimeter. Wow, we are going to reduce the perimeter. Definitely it is an economical option. So in order to make this discharge maximum, we have to reduce this perimeter, right? So we can say a most efficient channel section will have a maximum discharge for a minimum wetted perimeter. So you should keep that in mind that when I said economical or efficient, we should have minimum cost of construction for a maximum discharge. For that condition, we should get the minimum wetted perimeter in order to achieve this maximum discharge. So let us see the conditions for most economical channels. Sections for various channels, rectangular, trapezoidal and circular. Straight away we are moving to the most economical rectangular channel. So we have this condition that minimum perimeter for maximum discharge. So this is our channel with a bed slope S and width B and depth of the channel as Y. So we have area is equal to B into Y, where B is the width of the channel, Y is the depth of the channel, and vector perimeter can be written as B plus Y is equal to B plus 2Y. So I'm substituting this equation number 1, area is equal to B into Y, into the equation number 2, perimeter is equal to B plus 2Y, then the equation 2 becomes a by y plus 2y. And we have p is equal to a by y plus 2y. So for keeping this channel most economical and efficient, we should have a minimum cross-sectional area or minimum wetted perimeter, that is dp by dy should be 0. So I'm substituting the value p in this equation. We will get d by dy of a by y plus 2y, which is should be equal to 0. And when I differentiate this equation, you will get minus a by y square plus 2 is equal to 0, or a is equal to 2 into y square, right? So area is equal to 2 into y square, and we know the area of a rectangular channel section is b into y. So just now we found out area is equal to 2y square, so 2y square is equal to b into y, and y got cancel on both sides, then b will be equal to 2y. So this is our equation for width of the channel, that is width of the channel should be equal to the twice the depth of the channel. So what will be the perimeter then? We have perimeter equation as b plus 2y, and b here it is found that 2y plus 2y, which is 4y. So perimeter is 4y. Now I can find the hydraulic mean depth. M is equal to area divided by perimeter. We have area as 2y square and perimeter as 4y. So M will become y by 2. Right? So these are the conditions for rectangular channel section to be the most economical and efficient. That is, width should be equal to twice its depth. That is, B will be equal to 2y. And hydraulic mean depth is half of the depth, that is M is equal to y by 2. So that was all about most economical rectangular channel section. Now let us move to most economical trapezoidal channel section. So the condition for most economical and efficient trapezoidal channel section is same as the condition for rectangular. So for any channel section to be most economical and efficient, the minimum perimeter should give a maximum discharge. So the trapezoidal channel section will be like this. We have two sloping sides and a base. So let us see how can we calculate, or how can we find out the conditions for trapezoidal channel section to be most economical. So here we have here is a pictorial representation of cross section of a trapezoidal channel. We have base width as b and depth as y and top width as t. So the slope of the section, the channel trapezoidal channel section, is given as z horizontal to 1 vertical, right? So we have to find out the area, perimeter, and then hydraulic radius. So in order to find out the area, we are going to divide this entire channel section into 3 sections. First section is a triangular section, second section is a rectangular section, and third section is also a triangular section. So I'm taking the first section. So area of this trapezoidal channel section A can be written as area of the channel section 1 plus area of the rectangular section plus area of the last triangular section. So here we have a triangular section with y as depth and 1 vertical to z horizontal as the slope. So when we say 1 vertical to z horizontal, it means in order to reach a 1 meter height, we have to travel z meter horizontally. Okay, so in order to get 1 meter height, we have to travel z meter horizontally. So in order to achieve y meter vertically, how much length should we cover in horizontal? It will be z into y, z times y. So I can say from this triangular section, if y is the depth or altitude and 1 in z is the slope, then the distance or length of this base will be z times y. Okay, clear? So this length will be zy, and this, from the figure we know this is b, and another zy. So we can write top width. Top width T is given as zy plus b plus zy, which is equal to b plus 2zy. Okay, so this is the top width. So now we have to find out the area of this trapezoidal section. So we have divided this trapezoid into 3 sections. First section is a triangular section. Second section is rectangular section. Third section is another triangular section. So I am just drawing this triangular section separately. Okay, we have base zy and altitude y. So the area of the triangular section, that is A1, which is equal to half into y into zy, which is equal to half into zy square. So I can write total area of the trapezoid is equal to area of section 1 plus area of section 2 plus area of section 3. Now we have area of section 1 is half into zy square, and section 2 is a rectangle with base width b and y as depth. So the area is b into y, and third section is also another triangle with same area, half into zy square. So all this area we will get 2 into half y into zy square plus by, or which is equal to z half into y into zy into 2 plus by, which is equal to zy squared plus by, or I can also write b plus zy all into y. So this is the area of a trapezoidal section. Now we have to find out the perimeter. Now we have a triangle, two triangles and a rectangle. We know the perimeter is the length of this length, side slope plus base width plus another side slope, right? So we have this one as y and this is zy. Then the length of the side slope will be root of zy whole square plus y square, right? So I can write this one as side slope length is root of z square y square plus y square, which again is a, I'm taking y square outside, so y in the root of 1 plus z square. So this is the length of a sloping side. So now we can write the perimeter as length of sloping side 1 y in the root of 1 plus z square plus b plus again the length of another sloping side, that is y in the root of 1 plus z square. So I can write it as b plus 2y in the root of 1 plus z square. So this is the perimeter. Now we have our condition for most economical channel section should have P minimum, that is wetted perimeter minimum, or it can be written as dP by dy is equal to 0, and we have the equation for P, that is dP by dy. We have P is equal to, so P is equal to B plus 2y in the root of 1 plus z square, and we have area as b plus zy into y. So I am substituting the value of b from this equation number 1. B can be written as a by y minus zy. Fine. I'm taking the y from this side to the left hand side, then it will become a by y. Then b plus zy is equal to a by y, or b is equal to a by y minus zy. Now I am substituting this equation into this equation, and this equation will become p is equal to a by y minus 2y minus zy plus 2y into root of 1 plus z square. Okay, so we are going to find out the value of dp by dy. So we are going to differentiate the perimeter with respect to the depth. That is dp by dy is equal to 0. So d by dy of, here we have a by y minus zy plus 2y in the root of 1 plus z square is equal to 0. By differentiating, you will get minus a by y square minus z plus 2 in the root of 1 plus z square is equal to 0. So I am taking this negative terms into right hand side. This equation will become 2 in the root of 1 plus z square is equal to a by y square plus z. Fine. So I am substituting the value of a again here, that is b plus zy into y, into this equation. Then this equation will become 2 in the root of 1 plus, let me change the color, otherwise you will get confused. 2 in the root of 1 plus z square is equal to b plus zy into y divided by y square plus z. That is 2 plus, that is b plus zy into y divided by y square plus z equal to 2 in the root of 1 plus z square. I'm just cancelling this both y terms from numerator and denominator, then it will become b plus zy by y plus z is equal to 2 into root of 1 plus z square. And multiplying y with z here and here, you will get b plus zy divided by y is equal to 2 into root of 1 plus z square. So b plus 2zy divided by y is equal to 2 in the root of 1 plus z square, and taking the 2 here and keeping the y on that other side, this equation will become b plus 2zy divided by 2 is equal to y in the root of 1 plus z square. Okay, now let us see what is this b plus 2zy by 2. This was b plus 2zy was top width. So this is top width divided by 2. Top width divided by 2. And y in the root of 1 plus z square is length of a slope side. Length of the slope. So top width divided by 2 is equal to length of the top side. So t by 2 is equal to sloping side divided by 2. So t by 2 is equal to sloping side, length of the sloping side. So first condition for trapezoidal section to be economical or most efficient is half of the top width is equal to length of one sloping side. Now let us see the value of m. We have m is equal to a by p, area divided by perimeter, and we have area as b plus zy into y. So I'm writing this b plus zy into y divided by perimeter was b plus 2y into root of 1 plus z square. From this we know it is literally b plus 2zy divided by 2 is equal to y in the root of 1 plus z square. I can also write b plus 2zy is equal to 2y in the root of 1 plus z square. So for 2y into 1 plus z square, I can substitute that value, this value, with b plus 2y in the denominator of this equation. Then it will become b plus zy into y divided by b plus, instead of 2 by root 1 plus z square, I am writing b plus 2zy itself. So it will become b plus zy into y divided by 2b plus 2zy, which is 2 times b plus zy, right? So 2 times b plus zy. Now we got b plus zy numerator and denominator. I'm just cancelling it out. Now you will get the answer as y by 2. That is n is equal to y by 2. So this is the second condition for becoming a trapezoidal channel. And there is one more condition for a trapezoidal channel to be most economical. That is, when we draw a semicircular, keeping its center at the midpoint of the top width of this trapezoidal channel, and radius of this semicircle is equal to the depth of the channel. Say the depth of the channel is y. So here it is given as y, and b is the width of the channel. And if the radius of this channel is equal to the depth y, and semicircle is drawn by keeping its center at the midpoint of the top end or top width of this particular trapezoidal channel. So let us see. Let theta be the angle made by the sloping side with the horizontal. If this is theta, this will also be theta. So let me consider a triangle KAM. Okay, so triangle KAM. In this triangle, when I take sine theta, it will be MK divided by MH, MA, which is MK is the depth of the channel and MA is the side slope. Okay, so sine theta is equal to y by MA. Now taking another triangle OM and F, triangle OM and F. Here we have sine theta as sine theta will be OF divided by OM. This will be 90 degree. This will also be 90 degree. So these both triangles are right angle triangle. So OF divided by OM will give you this sine theta. So OF is y. Since the radius of this circular section is y, so y by OM. So we have two equations. Y by sine theta is equal to y by MA and sine theta is equal to y by OM. So I can write sine theta, which is equal to y by MA is equal to y by OM. Right? So from that equation, I can write y by MA is equal to y by OM. That is, MA will be equal to OM. Now let us see what is MA and OM. So MA is sloping side, length of the sloping side, and OM is half of the top width. Right? So when We say half of the top width is equal to T by 2 is equal to sloping side distance. This is a equation or condition for most economical trapezoidal section. So if we draw a semicircular section by keeping the center as at the midpoint of the top width, that semicircle will have will touch all the three sides of this trapezoidal channel section, and thus we can say the sides of this channel will be tangential to the semicircle. So this is the third condition for a trapezoidal channel to be most economical. So we can say if a semicircle is drawn from O with radius equal to the depth of the flow, it will touch all the three sides of the most economical channel section. So now we have the conditions for trapezoidal channel section to be most economical. And the first condition is half of the top width is equal to the sloping side of the channel, that is b plus 2y by 2 is equal to y into root of 1 plus z square. And the second condition is hydraulic mean depth is the half of the depth, that is m is equal to y by 2. And the third condition is if a semicircle drawn from O with a radius equal to depth of the flow will touch all three sides of the most economical trapezoidal channel section. Okay, thank you.